As our planet warms up, there's this incredible story unfolding, literally right under the waves. All this marine life, especially fish, they're on the move. It's like this massive global race away from the equator, towards the cooler poles. It's one of the clearest signs we have of climate change happening in our oceans.
So this brings up a question. And honestly, the answer seems kind of obvious, right? If a species can just pack up and move to a better neighborhood when its home gets too hot, you'd think they're the adaptable ones, the success stories, the so-called winners of climate change. But what if that simple, totally logical idea is just completely wrong?
All right, let's dive right in. First off, that basic idea, it's 100% true. We are absolutely witnessing this giant fish migration in real time. We're talking countless species shifting their entire home range, heading for the poles, just trying to follow the water temperatures they need to survive.
And for a long time, the main idea in the scientific community was this thing called the shift advantageous outcome. It's a pretty simple concept, really. It just means that being able to move fast is a good thing. It's a sign of resilience. The thinking was that these species are successfully keeping up with climate change, so their populations ought to be doing just fine, maybe even growing.
So here's what everyone thought that march to the poles would look like. You've got the back end of their range, the part closer to the equator, where the water's getting too hot. So yeah, populations there are going to shrink. But at the front end, the poleward edge, they're moving into new, cooler waters. And you'd expect those pioneer populations to be just booming, right? A simple swap, a march to safety. Makes perfect sense. But here's the multi-million-dollar question. Does this neat and tidy theory actually hold up in the real world? Well, a massive global study decided to find out. They wanted to connect the dots, to see if how fast a species is moving has anything to do with how its population is actually doing.
And when I say massive, I am not kidding. Researchers looked at, get this, 2,572 different population studies from all over the world's oceans. So we're not talking about a couple of fish here and there. This was a true global deep dive.
And their method was just brilliantly simple. They took all the data on how fast different species were moving, and they laid it right next to the data on whether the local populations of those exact same species were growing or shrinking, a direct comparison.
And what they found? Well, it completely flips everything we thought we knew on its head. The results weren't just a little bit off from that nice march scenario. No, they were the exact opposite.
So the big takeaway, to put it as simply as possible, is that the shift advantageous assumption is wrong. Flat out. Being a fast mover isn't a sign of success. Turns out it's a huge red flag. And the actual numbers are pretty shocking. The study found that the species that were shifting the fastest, we're talking about moving more than 10 miles a year, their populations had dropped by an average of 50%. 50! And that's over just a 10-year period. Wow.
The study's authors themselves put it crystal clear. They said, our findings contradict the perception that rapid range shifts indicate a successful response to climate change. It's like the fastest runners in this race aren't winning, they're collapsing. And this isn't just some abstract statistic, Look at these real-world examples. The pouting fish, it shifted almost 18 kilometers a year, and its population just plummeted by nearly 93%. Or the greater pipefish moved 25 kilometers a year and saw a 75% decline. These are absolutely dramatic collapses happening right now. Okay, but the story gets even weirder, because the researchers didn't stop there. They dug deeper to see where exactly these populations were declining, and what they found is a total paradox.
So, remember the expectation, right? The populations at the front of the line, the pioneers moving into that new, cooler territory, they should be thriving. But the reality? It's the complete opposite. For these fast-moving fish, it's those poleward, pioneer populations that are actually experiencing the worst declines of all. How does that even make sense?
This discovery just completely shatters that old March model. So the scientists came up with a new one they call poleward skewed abundance. Basically, instead of this nice, neat wave moving forward, the whole population gets warped. It's the front line, the pioneers who are supposed to be the strongest, that are unexpectedly getting hammered the hardest.
So, what on earth is going on here? Well, the study suggests that these fast movers aren't resilient at all. They might actually be the most sensitive species out there. They're not marching into some perfect, stable paradise. Instead, they could be running headfirst into new areas with wild temperature swings or other kinds of stress that those lead populations just aren't equipped to handle.
All of this, it forces us to completely rethink our whole idea of who the winners and losers of climate change really are, especially in the ocean.
So what's the big takeaway here for you? Well, first, the fastest moving fish are not the climate winners. They're actually incredibly vulnerable. And that means our conservation plans might need to focus on the very species we all thought were doing okay. And this is crucial. The population drops aren't just happening at the hot back end of their range. They're happening everywhere, especially at that supposedly safe, cooler front edge.
And you know, for anyone out there thinking, well, maybe this is just about overfishing, the researchers already thought of that. They controlled for it. And this pattern still holds up, even for fish that aren't heavily fished. So while fishing is obviously a massive deal, this particular signal of decline seems to be really strongly linked to climate.
So all of this leaves us with a really unsettling final thought. We just assumed that the species that could run the fastest, the ones that could keep pace with a changing climate, were the ones that were going to make it. But all this evidence shows they might be the most fragile of all. So if the fastest runners are actually losing the race, who is winning? Is anyone?